তো অলমোস্ট সবগুলো মিলেই এভাবে আমাদের এগোতে হবে। তো থিওরিটা কিন্তু ভালো করে জানতে হবে। যতই আমি নিউমেরিক্যাল করি না কেন, থিওরি যদি ঠিকঠাক না জানি, নেটে কিন্তু স্কোর করাটা চাপ আছে। ঠিক আছে, নেটে এখন যেভাবে কোশ্চেন প্যাটার্ন আসছে, আগে যেমন কি হতো, ফর্মুলা জেনে যেতাম, জাস্ট পুট করলে হয়ে যেত, এখন কিন্তু সেরকম সিস্টেমটা নেই। এখন আমাকে থিওরির উপরে যথেষ্ট কমান্ড রাখতে হবে, না হলে কিন্তু হবে না। ঠিক আছে, তো আজকে ওদের যেহেতু এক্সাম আছে, ওরা পরে ভিডিওগুলো দেখে নেবে, রেকর্ড করবি পুরো। আজকে দুটো পার্টে ক্লাস হবে। ফার্স্ট পার্টে আমি ক্লাসিক্যাল মেকানিক্স করবো, আর সেকেন্ড পার্টে হচ্ছে কোয়ান্টাম ফিল্ড থিওরি। ঠিক আছে, এমএসসির পার্টটা জানা দরকার, এমএসসি তে বেশিরভাগ লোক এগুলো স্কিপ করে গেছিল, তো সেই জন্য দুটো পার্টে আমি ক্লাসটাকে রেখেছি আজকে। ঠিক আছে, তো the first episode of this class mainly deals with the fundamentals of classical mechanics. Basically, we are starting from the Lagrangian dynamics. Okay, Lagrangian formulation of dynamics. Okay, so at first, before going to the Lagrangian formulation of the dynamics, we have to discuss about some basic formulation or basic tools which we can use to formulate the Lagrangian formulation or obtain the Lagrangian formulation, or basically the Euler-Lagrangian equation. The basic thing or basic principle in classical mechanics is the variational principle. Okay, variational principle. And another variant of this variational principle is principle of least action. Principle of least action. There are two variants of this principle. Mainly the general form of this principle is the variational principle, and some special variant of this variational principle is the principle of least action. So at first, try to understand what the basic formulation of variational principle is. Okay, so at first we have to know about the functional. Can anyone know what is functional? Anyone? Okay, what do you mean by a functional? Okay, I am trying to describe this thing. Functional is basically a function, or mapping. Okay, function or mapping which maps from the vector space to the corresponding field. Okay, so suppose I am saying, suppose S is a functional. So what is functional? Functional means it's a function or mapping which maps from the which maps the elements of a vector space to the corresponding field. Suppose I am writing, this is suppose Vn to V. Okay, so this is a functional because Vn is a n-dimensional vector space and V is the corresponding field. Okay, so the element of V, they are basically scalars, and the elements of Vn, those are basically vectors. So it can convert a vector or some set of vectors to some corresponding scalars. Okay, so this is functional. So at first, let take some examples. For example, example of functional, the very popular and familiar example of functional is the dot product. Is dot product of normal vectors. That means common vectors actually, of common vectors. I am saying common vectors because actually all the elements of vector space are called the vectors. In that sense, matrix are also vectors, complex numbers, polynomials, the wave functions, all these can be termed as the vectors. But I am saying the common vectors. That means the vectors which you learned, which you have learned in your schooling, or the normal vectors, the forces, the velocities, accelerations, the common vectors, the dot product of common vectors. Okay, so suppose a and b those belongs to R3 because three-dimensional real vector space. R3 is the Euclidean space or three-dimensional real vector space. And if you take a dot b means you can say ax bx plus ay by plus az bz. So this is a scalar. A, B both are vectors, but a dot b, that means the dot product of a and b, these are basically scalars because the sum of scalars, sum of some particular scalars. So if you define, suppose f of ab is equal to a dot b, it is a functional. It is a functional because it maps the vectors to the scalars. Okay. So it's a very familiar example of a functional, and in that sense, the inner product which you generally use in the vector space term. So any inner product are the functional because any inner product is defined to find the elements of field from the elements of the vector space. Okay, suppose a b or psi phi in general. Suppose psi phi, those belongs to suppose Vn, and the inner product of psi phi, those belongs to V. So basically, this is also the functional. So uh, any inner product, you can say these are actually the functional. Okay, so any inner product is a functional. So this is functional. So starting from the example and the definition from the functional, we have already learned functional is basically a function or mapping which maps from the vector space to the corresponding field, and the examples are there. Generally the dot product and also any inner product, because dot product is a special type of just example of inner product. So obviously any inner product is the functional. So the dot product is also a functional. Now, now I am going to define another functional. Suppose f is function of suppose y dy by dx and x, and also y depends on x itself. So f is such a function. F is the function of y, f is the function of dy by dx, and also it is dependent on x, and the y are also dependent on x, and dy by dx also depends on x. So basically f depends on x explicitly and implicitly. Because explicitly, because the expression of f may contain x itself in its expression explicitly, And also f contains y and dy by dx, which are the function of x. So basically f has the explicit dependence and also the implicit dependence on x. Okay, now suppose I define s equal to integration from some x1 to x2, the definite integral of f y of x dy by dx, which is also function of x, and x dx. Now it's a definite integral, and you know in a definite integral after integration you have to put the limit, and you have done the integration over dx, and after the integration you have to put the limit of x from x1 to x2. So just after integration, s does not depend s does not depend on the x. So is uh, s is independent. S is independent on x. So this is a functional because f depends on x, so it has some extra dimension. You can say this is the element of some vector space, and after integration you will find s. S is independent on x. So s is like the scalar. So it's like a scalar, and this f is a vector. So you can you have just constructed some scalars s from the vector f. So in that sense, s is a functional. So here s, you can say this is functional. S is functional, and I am writing s is suppose f y, and dy by dx I am writing in the shorter notation y dot x dx, and it's from suppose x1 to x2. I am writing the shorter notation y dot is equal to dy by dx. Okay, so this is functional. Okay, and what is action basically? Can anyone say what is action? Anyone? Anyone from you? What do you mean by action? Not Lagrangian actually. Actually, what is action? Action is functional of time. Okay, action is functional of time basically. Any action is the functional of time. So you know the term Lagrangian from the previous knowledge of classical mechanics. Lagrangian. Okay. So Lagrangian is denoted as L, and L is nothing but the difference of the kinetic energy and potential energy. And generally kinetic energy is half of mv square. So it is suppose half of m q dot square. Suppose for one dimensional system, only one coordinate is there. Suppose q, so half of m q dot square minus potential energy. It's generally function of q. Okay, you can say the harmonic oscillator half of m omega square q square. You can say any system you may consider which are basically the potential is dependent on the coordinates. So the Lagrangian L is the function of qk dot, which is dq by dt and t. And also these coordinates are implicitly dependent on t in the same way. So if you define some functional like that, suppose from t1 to t2, L dt, it is called action. So action is an example of functional. Sorry, action is an functional of action is an example of functional. Okay, so it's a functional of time, and of course, Sahil is right because Lagrangian is the function. Lagrangian depends on time explicitly and implicitly. So from there you can define the action A is equal to L dt. Okay. Now go to the general form. So we have the functional basically. Now we have functional S, and it's just a special type of functional which you can term it as the action. Okay. Now now consider a system. Suppose any system any system, you can say, any system. And in dynamics, we have to track the evolution of the system. Okay, you have to track the evolution of the system. In general, in physics or especially in dynamics, what is your main purpose? The purpose is to track the evolution of the evolution of the system. In dynamics, you have to track the path. You have to track the path, kinematic path or mechanical path. Basically, the right term should be mechanical path. Okay. In thermodynamics, you have to track the thermodynamic path. Okay, you have to track the thermodynamic path, because in thermodynamics you have to find out what type of thermodynamic process is that. Is whether it is the isothermal process, whether it is the adiabatic process, or what kind of process it may be. You have to track that. In other branches of physics, you have to just track the motion, the flow of the system, or in a better language, you have to say that the evolution of the system. Okay, the main purpose of studying physics is basically to track or to study the evolution of any system. Okay, and itself, universe is a system, and the for for tracking the evolution of our universe, you have to study the cosmology. Okay, so in general, in physics, you have to track the evolution of any system, and you have the different branches in physics. In dynamics, you have to track the mechanical evolution. That means in which path it is going to evolve. It is going to evolve. Okay, in thermodynamics, you have to track the thermodynamic paths. In other branches of physics, you have to track the corresponding paths or corresponding processes. So in general, suppose the system is here initially. So this is the initial point of the initial point I of the system, and after some time or after some interval, it goes to the final point A. So initially the system is at I, and after some interval, after some interval it goes to F. Okay, so the system evolves from I to F, and this evolution may not be the physical path only. It may be the thermodynamic evolution. Suppose in thermodynamic cases, you can, for example, you can say the system is at Pi Vi Ti. For thermodynamic case, the system was at Pi Vi Ti. T means the temperature, and after some time it goes to, suppose, Pf Vf Tf. Okay. In thermodynamics, the thermodynamic evolution will be from initial thermodynamic state to final thermodynamic state. And in thermodynamics, the thermodynamic states are actually denoted by the thermodynamic coordinates, namely pressure, volume, temperature, PVT. Okay. In dynamics, you can say, suppose the system is at suppose Qi, Vi, Ti, and it goes to Qf, Vf, Tf. Q is the position, V is the velocity. It may be done, it may be taken. Or in any branch of physics, basically the corresponding state of the system which will be evolved from I to F, from initial point to the final point. Okay. But the evolution may be in different paths. The system may be evolved in different paths, not only one path. Okay, you have several different paths, and the number of possible paths or the number of possible processes through which the system can evolve is infinite. There may be infinite number of possible paths. Okay, you can take some examples. Suppose you have 2 points in space. How can you connect them? In how many ways you can connect them? Anyone? Please respond. In how many possible ways you can connect the 2 points? Infinite, exactly. Okay, there are infinite number of different ways or different paths through which you can connect the 2 points in space. Similarly, any system can be connected through different possible paths or different possible processes. So the system can evolve in different processes. Okay, but among among this infinite number of possible paths, the system is constrained to move along a particular path. The system is constrained. Okay, suppose you have to go from Panchkula to Howrah. Okay, so there may be infinite number of possible paths, but you chose the railway track. Why? Because your motion is constrained, your motion is restricted along that path, and in order to do that, you have to put some effort or you have to apply some force, namely the force of constraint. Okay, and the force of constraint for that particular case is the normal reaction on the train. Okay, so what does it mean? Actually, among infinite number of possible paths, if you choose one particular path, that means you are constrained to move along that path by applying the force of constraint. Okay, but my question is something different. My question is, suppose you have 2 points I and F, and you are not restricted to move along any path. You have no constraint on the system, and in that condition, in which path the system will flow spontaneously? Okay, is my question clear to you? My question is, or my purpose is to, we have a system which evolves from I to F. Okay, initially the system will be at I, and after some interval it will go to F. And I have not imposed any constraint on the system, or I have not okay imposed any sort of restriction on the system, or any sort of restriction or constraint on the system. Now my question is, in that situation, because the system is allowed to evolve spontaneously, so in such condition, which path the system will follow? Any idea? No, that's not the correct answer, because the definition of shortest path is not very clear, because this path is not the physical path. You mean this path may be the thermodynamic path, this may be in any path. So this is not a general complete answer that the path will be shortest distance path. Okay, the right answer is the system will follow such a path spontaneously where the variation of the path will be zero. Okay, suppose the system will follow this path. Suppose this is path number 1. That means the variation of the functional along that path will be 0. So that means the delta of S is equal to 0. Sorry, delta S will be 0. The system will choose such a path. Okay, the system will choose such a path where the variation of the functional will be 0. That means S will be minimum or maximum. Because the first order derivative is 0, that will imply the quantity will be maximum or minimum. So the action, that means the functional is extremum. That means the variation of the functional will be 0. And this is called the variational principle. Okay, variational principle. So what does variational principle say? Variational principle say if you don't apply any constant on any system, the spontaneous path in which the system will flow is that special type of path where the variation of functional is 0. And in other words, the functional will be minimum or maximum. That means the extremum. Okay. And for action, suppose you choose this for the Lagrangian of the Lagrangian case, then it will be delta A is equal to 0, and this is called the principle of least action. Principle of least action. So basically, these two are the same thing. Just example of variational principle is the principle of least action. Okay, so this is variational principle. And what is the outcome of this? The outcome is very clear. Suppose you choose some one path where the functional is the function of, suppose, y function of x, y dot function of x, and x, and after some variation it will be the function of y plus, suppose, delta y, and y dot plus delta y dot and x. Is a small variation in the function a. It's not the functional. Okay, mind it. This is not the functional. The functional is integration of that. Okay, so there will be small variation in f, although there will be no variation in the functional. Okay, so suppose this is one path, and this is very second path. So here the value of y, this is y dot and x, and along this path it will be y plus delta y dot plus delta y dot and x. And it is very clear that the variation, that means the variation is here delta y and delta y dot is 0. Suppose this is the I point and this is f point. So delta y at I equals to delta y at f is equal to 0. As well as delta y dot at I equals to delta y dot at f equals to 0, because the path may be different in other points, but at the two ends I and f, the value of y dot x will be same. So that means the variation will be 0 at the two fag end of the path. Okay, and also delta y tends to 0 and delta y dot also tends to 0, where not in I and f. Okay, মানে I or fa equal to 0, but in other points they are not 0. Of course, we can't claim that they are 0, but they are very small, because we are taking some very infinitesimal change in path. Okay, so from variational principle you can say that, from variational principle you can say that integration of, suppose it's from I to f. Okay, so you have f y plus delta y dot plus delta y dot x dx minus I to f of y dot x dx, that will be equals to 0. And now we have to take the Taylor series, and you have to put the first order dependence on the variation, because delta y is very small. At the two end it is 0, of course, and in other points delta y and delta y dot are very small. So you can keep the first order term till the first order term. The second order will be very irrelevant, because delta y is very small, their square will be very irrelevant, cube also. So you can neglect the higher order dependence on the delta y and delta y dot. You can put the first order term. So you can find from here, it will be first term will be f of y dot x. Okay, then there will be del f by del y into delta y plus del f by del y dot delta of y dot dx, and the higher order of delta y and delta y dot. So those are basically negligible for our prescription, because those are very small, minus from I to f f of y dot x dx equals to 0. And also these two terms will be cancelled out. It is also very clear, because these are same. Now you can find from I to f del f by del y delta y, it is okay, and the second term is del f by del y dot into delta y dot of dx equals to 0. Okay. Now look at the second term. From second term, del f by del y delta y dx. The second term, you can take the by parts. So this is u, suppose. This is u and this is v. So the first term is del f by del y dot, and the integration of del y dot will be delta y. It's from I to f, and then minus and minus and minus is basically plus. Sorry, this one was plus. So this one will be plus, but this one will be minus. Okay, so from here it will be from integration I to f dy dx of u. That means del f by del y dot and integration of delta y and again integration, it will be 0. And as per our prescription, delta y, that means the variation is 0 at I and f, so it will yield 0. Okay, it will yield 0. So now you have integration from I to f del f by del y minus dy dx of del f by del y dot of dx and also delta y equals to 0, and dx and delta y are arbitrary elements, so they cannot be taken generally 0, so the integrand will be 0. So you have del f by del y minus dy dx of del f by del y dot is equal to 0. So this is the outcome of the variational principle. Okay, and this is called Euler-Lagrangian equation. This is called Euler-Lagrangian equation. Okay, any question till now from any one of you? Any question? Hmm? Hmm. মানে জেনারেলাইজড কোঅর্ডিনেটটার ব্যাপার আমি এখনো বলিনি যদিও বা, ঠিক আছে, যখন আলোচনা হবে বলবো একটু সিস্টেমটা, কিছু এক্সাম্পল আলোচনা করব, তখন আমরা বুঝতে পারবো। Okay, so I think I have to proceed. So this is Euler-Lagrangian equation. Okay, now another question from myself. Suppose this functional is now the function of y dot and y double dot x. So what should be the change in the Euler-Lagrangian equation? It will be similar, or you have some change in the Euler-Lagrangian equation? কোনো চেঞ্জ আসবে না একই রকম থাকবে Euler-Lagrangian equation? না, করে একই রকম আসবে। Actually, the homework for you, it is very easy to show. It will be del f by del y minus dy dx of del f by del y dot plus d2 dx2 of del f by del y double dot equals to 0. And in general, suppose f is function of y dot, y double dot, y triple dot up to nth order derivative of y and x. That in that case, actually you have del f by del y minus dy dx of del f by del y dot plus d2 dx2 of del f by del y double dot and so on, minus 1 whole to the power n dn dxn of del f by del of yn, nth order derivative, is equal to 0. So it is the general form of Euler-Lagrangian equation for any higher order dependence on y. Okay. Okay. This is not very important. The important thing is our system is not so complicated. Our general systems are generally dependent up to the first order, so it is okay to continue with the first order. But in some rare cases, you may find the second order dependence in very rare cases. But in general, nth order dependence, it's very awkward. Okay, you can't find any practical system where you will find such type of equations. So for the time being, you can neglect this one. But this is homework for you, so that this equation holds. Okay. Uh, Now for the Lagrangian case, the equation will be dy dt of del L by del Qk dot minus del L by del Qk equals to 0, where Qk are the generalized coordinates, the minimum number of coordinates which are very mutually independent to each other. Those are the generalized coordinates, and the number of such coordinates in a coordinate system is called the degrees of freedom. So k runs from 1, 2, 3 up to f. F is basically the degrees of freedom. Okay. So this is Euler-Lagrangian equation, and this equation is the variant or example of a particular or general Euler-Lagrangian equation. It is called the Lagrange's equation of first kind. Lagrange's equation of first kind. It is okay. Lagrange's equation of first kind. So this is the Lagrangian formulation, which are basically the outcomes of general variational principle. The other application of variational principle is basically the shortest time path or shortest distance path, basically. Shortest distance path in R3. And second is Brachistocone problem, that means shortest time path in R3. And those problems are very popular to you in general classes. I have discussed a lot on these two problems, and I am going to leave you for the homework. Okay, so you have to check this one. The shortest distance path will be the straight line path, and the shortest time path, that means the Brachistocone path, it will be the cycloid type of path, and it is I am going to leave you for the homework. Okay. Now we are going to concentrate fully on the mechanics. It's not the part of mechanics. It's from the general application of the variational principle. Okay. But for the time being, we are going to focus on the classical mechanics. Classical mechanics. Okay. And in classical mechanics, the Euler-Lagrangian equation has a special variant, which is dy dt of del L by del Qk dot minus del L by del Qk equals to 0. Mind it, while applying this equation, you must have to express the L in terms of Qk. L must be the function of L should be, not should be, actually must be the function of Qk, Qk dot and T, and Qk are the generalized coordinate, not the arbitrary coordinate. Okay, Q is not the arbitrary coordinate. You have to be very careful about writing the expression of Lagrangian. Lagrangian never be written in the form of the arbitrary coordinate. Lagrangian must be written in the form of generalized coordinate. Okay, let's take some common mistake about this case. Okay, you have some common system which is etude machine. Etude machine. What do you mean by etude machine? It's a mass pulley system. Okay. Suppose this mass is small m and this mass is capital M. The position vector with respect to this origin is for R1 and it's R2. And the pulley and the string are basically massless. Okay. Now suppose the kinetic energy. Kinetic energy of the system will be half of small m R1 dot square plus half of capital M R2 dot square. And the potential energy is minus mgr because it's under gravity. So minus mg of r1 and minus of mg, sorry, mg of r2. So the Lagrangian L will be function of t minus b. So you can write this is half of m r1 dot square minus half of m r2 dot square minus m1g, sorry, m, basically small m g r1 minus mg, and so minus minus plus mgr, capital mgr2. So this is our Lagrangian. So clearly you can use del L by del R1. What will it? What will it? Del L by del R1 means mg. This is mg. And del L by del R1 dot, it is basically m R1 dot. M R1 dot. So d by dt of that, it will be m R1 double dot. So from here you have R1 double dot equals to z. But is it okay? Is it R1 double dot is z? This system is very popular to you, and the result is R1 double dot equals to minus of R2 double dot, which was m minus m by m plus m into z. এটা অ্যান্সার হওয়ার কথা ছিল, কিন্তু পেয়েছি কি এই জিনিসটা। So is it okay? The result is not okay, because what is the problem in this mechanism? We have taken the Lagrangian, all are okay, but the result does not match with our known result. So what is the issue with this? কেউ বলতে পারবে যে প্রবলেমটা কোথায় হয়েছে, কেন অ্যান্সার আসছে না? Why? You have the kinetic energy, this one and this one. I have quickly written although. And the potential energy is minus mg. So for this one is minus mgr1, and for this one is minus capital mgr2, and you have all of these Lagrangians. Okay, actually this was plus. It does not make any change in the result. So you have L. I have taken for R1 only. You may also take for R2. For R2 you will get the same thing, R2 double dot will be equal to z. But it will not match with the original result. The original result was that. Okay. So what is the problem with this formulation? What is the wrong with this formulation? I have taken everything, but still the result will not correct. The result will not be completely correct, because the result, known correct result is that, and you have gotten this one. The problem is taking the coordinates. You have taken the coordinate R1 and R2. Okay, the problem is in choosing the coordinate. You have chosen R1 and R2, but this R1 and R2, these are not independent to each other, because the string is inextensible. So you have R1 plus R2 is constant, which is L. So R1 and R2 are not the generalized coordinate, they are just arbitrary coordinates. Now there are only independent coordinate, which is R1 or R2. One thing may be independent, when another is dependent on R1. So R1 dot plus R2 dot, it will yield 0. Okay, so R1 dot equals to minus of R2 dot. Now you can write the Lagrangian. L equals to half of small m R1 dot square plus half of capital M R1 dot square, because R2 dot equal to minus of R1 dot, minus plus mg R1 plus capital M g L minus R1. So in that case, del L by del R1 equals to mg minus capital mg, and del L by del R1 dot, it will be m plus m into R1 dot. So from here you have R1 double dot equals to capital M minus small m by capital M plus small m into c. 1 minute. হ্যালো, হ্যাঁ বলুন। হ্যাঁ হ্যাঁ, আমি যাবো বলেছি, একটু দেরি হবে আর কি, আমি যাবো আজকে। হ্যাঁ 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 হ্যাঁ। হুম 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 হুম। হ্যাঁ কথা হয়েছে, আমি একটু দেরি হবে যেতে, কিন্তু যাবো আজকে। হুম হুম, ঠিক আছে। হুম। So the expression of the acceleration of R1 is that, and it is okay with your own result. It's a known familiar result of the acceleration, which is same. So if you choose the correct form of the coordinates, you will get the correct result. Okay. So in order to get the correct result, you have to write the Lagrangian in terms of the generalized coordinate. But if you make the mistakes of having the arbitrary coordinates, we will not definitely find the correct result. The result will be wrong. So be careful while choosing the coordinate system of representing any Lagrange. Okay. Now the second one. আচ্ছা, ক্লাসিক্যাল মেকানিক্সটা যতটা হলো সেটা এই অবধি থাক। এর অ্যাপ্লিকেশন গুলো দেখবো পরে, হ্যামিল্টনিয়ান তো হয়েছে, এগুলো জানা। এর উপরে আমি কিছু অঙ্ক দিয়ে দেবো, গ্রুপে অঙ্ক দিয়ে দেবো, সেগুলো তোমরা ট্রাই করবে। সেকেন্ড পোর্শন যেটা, ঠিক আছে, সাহিল হচ্ছে আলাদা ভাবে এটাকে রেকর্ড করবে। সেকেন্ড পোর্শন যেটা, সেটা হচ্ছে কি, সেটা আমরা ফিল্ড থিওরি নিয়ে আলোচনা করব, quantum field theory. So the second episode of today's class is the quantum field theory. I am leaving 2 minutes, আমি 2 মিনিট সময় দিচ্ছি একটু মাঝে গ্যাপ, তারপর আমরা সেকেন্ড পোর্শনটা আলোচনা শুরু করব, ঠিক আছে? The second portion is about quantum field theory. তো ফার্স্ট এপিসোডে যদি কারো কোনো কোশ্চেন থাকলে তোমরা আগে শেয়ার করো। কোনো প্রবলেম হওয়ার খুব একটা প্রশ্ন নেই, কারণ এগুলো খুব জানা জিনিস, আমি জাস্ট রিমাইন্ড করলাম। এবং নিউমারিক্যাল যেগুলো দেবো গ্রুপে, সেগুলো ঠিক আছে রেগুলারলি সেগুলোকে রেসপন্ড করার চেষ্টা করবে। হ্যাঁ। হুম। হ্যাঁ হ্যাঁ, নেট জাস্ট ওরিয়েন্টেড। হুম। হ্যাঁ হ্যাঁ, এটা অফ করে দিয়ে প্রথম থেকে হবে আবার।